Okay. Hello. Good
What
morning, everybody.
what's up,
Woo!
pre-calc? You
Hey
cool
y'all,
cats again?
and Miss Marshall this time.
It's your lovely pre-cal team. But again, some of this stuff you will see on a standardized test like the SAT or ACT, which is why we want to make sure that we get this information out to you. Okay, so we are going to start with something called a determinant. The determinant is known as a numerical value assigned to each matrix. It is really kind of a dumb number, but it is going to be used to find something called an inverse, which we'll talk about in a little bit. So in terms of an inverse, it's kind of important. We can only find it if we have a square matrix. And a square matrix is exactly what it sounds like. It's going to be in the shape of a square. Okay.
So, like, what would the dimensions be then?
Like they'd be a 2 by 2 or a 3 by 3 or
What
4
about
by
a 4 by
4.
3?
No, Miss Marshall,
But
not a 4
you
by
said a
3.
square.
4 by 3 is not a square, Miss Marshall.
Oh, I forgot.
Okay, so in order to find a determinant, we are going to use something that's called the diagonal method. The diagonal method, oh, let me back up a minute. If you look at this notation right here that looks like absolute value, that is the notation that's going to tell you, hey, find the determinant. Okay, it does not mean absolute value when we're talking about matrices. So the diagonal method for finding a determinant says to take A and D, which are on what we call the main diagonal, multiply them together, then subtract the minor diagonal, C and B, so that product. So that's what we're going to do for a 2 by 2 matrix. If you have anything larger than a 2 by 2, you would use something called Cramer's rule. And if you are really jazzed up about learning about matrices, you can watch a YouTube video to learn about Cramer's rule if you want. So
Hey, Fish,
yes.
can I do it the other way around? Like, what would I get the same answer if I multiplied the other diagonal and then subtracted?
No,
A and B?
because subtraction doesn't give you the same answer if you do it the other way around.
Duh, 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 duh.
Duh.
No, Miss Willis.
Hey, no shaming each other.
Oh,
okay.
you're smart, Miss Willis.
So in example 1, when it says evaluate each determinant for part A, all you need to do is multiply your main diagonal, so 6 times 3, and then subtract the minor diagonal, so 3 times 4. So you're going to get 18 minus 12 for a grand total of 6. So
Easy.
easy peasy. So in B, again, we see these absolute value bars now instead of a matrix symbol, but the absolute value bars mean find the determinant. So again, using our diagonal method, multiply your main diagonal. So 4 times 6, and then minus your minor diagonal. So -1 times 2. So you're going to get 24 minus -2 for a grand total of 26.
Wait, that's not going to be 22, though? I thought
No, because
24 minus 2.
minus a negative becomes plus positive, Miss Marshall.
Change.
Oh, that's right. Change. Got it.
All right. And that brings us to inverse matrices.
Woo! Why would you need it to solve that type of equation is the question. Because unlike with, and guys, I don't know why that's there. Oh, it disappeared. Okay, no, it didn't. In order to solve for x, we would typically say this is called matrix A and this is matrix B. Well, what we would normally do is not add matrix A, not subtract, but you probably think, oh, dividing is not allowed in matrices. Now, don't ask me why, but it's not allowed with matrices. So what we have to end up doing to solve this is multiplying, still multiplying, solve by multiplying by the inverse. You may have seen this before, but honestly, if you have not seen this before, this is not a recall. We are learning this for the first time. So when we deal with the first matrix, this one, ooh, okay, there we go. This one is 1, 1 in your main diagonals, as Miss Fisher was saying, and then 0, 0. This is just what this matrix is called when your main diagonal is 1s and all other spots are 0s. So this is what it looks like with a square matrix. That's a 2 by 2. And 1, 1, 1 for a square matrix, that is a 3 by 3. And literally all the other spots are 0s. And
Now,
this is
what's that called again?
This is the I matrix. This is the identity matrix. Right. Yeah. And so
Yep.
that means when you multiply A times B, two matrices, B times A, which you can do the inverse, the reciprocal, so A then in front or A in the back, when you multiply them, if they are truly multiplicative inverses, when you multiply them, whether it's A, B, B, A, you will get that I matrix as your answer. And that's how you can check if they're inverses of each other.
That's cool.
So cool. So cool. So we have this I matrix. Now let's show, for example, number 2, that A and B are multiplicative inverses of each other. So what in the world does that mean? Well, that means you got to do a little bit of work, like twice, because you have to check both ways, A times B. And then you have to, yes, indeed, check B times A, because they both have to multiply to get the I matrix in order to be multiplicative inverses.
Can we just do this in our calculator?
Yes, however, that part's at the end, so let's endure.
No, but we learned how to multiply already in the calculator, right?
Yeah.
Yeah, absolutely. However, on the SAT and ACT that, Ms. Fisher was talking about, there are calculator inactive parts. So if this popped up on the calculator inactive part, you would be so out of luck if you only know how to do it with a calculator. So let's do it without so that we won't be out of luck. All right. So 2, 3, 1, 2. That's matrix A times 2, -3, -1, 2, not a -2. We multiply those. All right, so we have already figured out how to multiply. And recapping, if you want to put it in your calculator, you totally can. But remember, you have to multiply the row. Oh, that's a bad highlight color. Let's get a better one. Let's see if this will show up. Oh, that's a little better. Row times column. So our row times our column is 4, because you have to multiply the numbers in the same spots, corresponding spots. So whatever's first in the row, whatever's first in the column, they multiply together, and that's where you get the 4. And then you multiply whatever's second in the row and what's second in the column, and that ends up being a -3. And you're technically going to add those numbers together. So 4 plus -3. You could always do 4 minus 3. It's totally the same situation. And then you want to do the same thing. So I'm going to do it one more time with the second column. So doing it again, multiplying these, boom, first thing in the first row, first thing in the second column. And so first times first, that's -3 or -6, not -3. And then second times second, 3 times 2, that's 6. So we're adding it together. You do the same thing for the next 2 rows, or the next row, not the next 2. Okay, let's put my 3 back. And we multiply first times first for this section, and that will be 2. And then multiply second times second, so that's -1 or -2, so plus -2. And then we do the same thing for the last one. Get rid of that highlight the last row or the last column. Ooh, columns, rows, columns, rows. The last column. And then first times first is -3. And second times second is +4. So we add it all together. And then we close up our matrix, and you actually have to add it together. And so final answer, boom, you end up getting 1, 0, 0, 1. Ta-da! It is indeed the I matrix, so that works. Now we have to do all of it all over again.
Marshall, your little -2, or at the bottom row, it looks like a -2. Is that supposed to be a -2 or a -3?
Oh, it's totally supposed to be a -3. Thank you. Type O. So -3, and then this is plus. Why? Because 1 times -3 is -3, not
Gotcha.
-2. So now we just have to do it literally the same exact thing all over again. So multiplying this one, but this time I put the 2, -3, because that's the B matrix. I put that one in front, and then I put 2, 3, 1, 2. I put that one in the back. The question is, why do we have to do this twice? Because isn't this multiplication, and multiplication is commutative? Yes, with integers, but multiplication is not commutative with matrices. You may have known that. Just to recap. All right, so now we multiply. We do literally the same thing all over again. I'm going to do it a rather quicker. So first times first, 4, second times second, -3. Then same thing, but with the next column, first times first, 6, second times second, -6. Doing it again, this time with the next row. I don't know why it's getting rid of everything. So put my -3 back. -3 and 2. So row and column, first times first, that's -2. Second times second, that's +2. And then the last one, get rid of everything. This thing just likes to delete the world. Okay, so that was a 1 there. And we have -3, first times first, and +4. And then, dun, 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 we get the identity matrix again. Once you
1001.
Yes! Woo! So these are indeed, therefore, A and B are multiplicative. Oh, this is such a long word. Inverses. Oh, and we're done. Okay. Will you have to check that? You may have to check to see if they are inverses of each other. So you need to know this. Are you allowed to use a calculator? Absolutely.
That's doing too much.
Doing way too much, man. Way too much.
Agreed. But sometimes you got to do too much to get the right answer. All right, so let's actually use this stuff. As you can see, we're previewing, we're going to use a calculator soon. But again, you may have to do this stuff by hand, like real talk. So just showing you how to do it by hand. When you have the rule to find the matrix or the inverse matrix, okay, here's how I like to think of it. You are going to do 1 over determinant, and I'm going to abbreviate determinant, and then flip, flop, opposite.
Flip, flop, opposite.
That's how I remember. 1 over determinant, flip, flop, opposite. 1 over determinant, flip, flop, opposite.
Opposite.
So, oh yes, put the whoop whoop in the background. So, where do I get this from? All right, this 1 over the determinant part, that's this. So 1 over determinant. So you already know how to find the determinant. Now it's like the flip-flop opposite, that part. Like what is that part? That part comes from the way that matrix looks compared to how it started. And so taking off those highlights, because I don't really like the way that blue looks. Here's how I write it. Flip-flop, and you're gonna flip-flop literally the main diagonal, as Miss Fisher said earlier, and then you're gonna put opposite or make the other diagonal opposite. So in other words, not negative, make it opposite, because if it starts out negative, it will be positive. But if it starts out positive, it will be negative. So that's why I say flip-flop opposite instead of flip-flop negative. Don't do that.
I like it.
Flip-flop opposite. All right. Let's begin. So we got to find, and remember, at the end of the day, that is finding the inverse matrix. That is how you do that. 1 over determinant, flip-flop opposite. 1 over determinant, flip-flop opposite. All right, step numero uno. Let's find the determinant. And remember, you multiply these two, and then you're going to subtract, multiply those two. So that is 8, because -2 times -4, minus 10, because 5 times 2. And that's -2. Yay! That's like the determinant. Now we got to find the inverse. 1 over determinant, flip-flop.
Flip-flop opposite.
Yeah! So we flip-flop these, -4, -2. And then remember, we make these two opposite. So -2, -5. Whoop, whoop, go us. And then now we can do some good old mental math. Yes, honey, because we can divide by twos, -2s. We can do it. So then that's +2, +1, 2.5, and 1. And yes, you can have
That's
a
it.
decimal in a matrix.
That's it. That's all we got to do.
Ta-da!
It's
Yes,
so
that's it.
easy.
It is. It took longer to figure out if they were inverses than it was to find the daggone inverse.
Yes, flip-flop opposite. I love it.
Whoop, whoop. So next one, last one, and then we can do a calculator. Multiply, subtract, multiply. So then that's -18 minus 18 equals 0. Dun, 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 dun.
It
So
doesn't. No, it doesn't. Negative
say that.
18 minus 18?
Oh, this is supposed to be positive. Oh my gosh. Why did I put a negative right there? I think this little negative spot right here messed me up. That ain't negative. This is actually 18 minus 18. So it is indeed 0. So what do we do when there's a 0? Well, we set it up the same way. /psych. Don't need to do all that, because what's wrong with a 0? Miss Willis, Miss Fisher?
You can't
You
divide.
can't divide by 0.
No. 0 on bottom is no. 0 on top is okay.
No, no. So whenever you have a 0 on the bottom, or rather, whenever your determinant is 0, then that means there is, therefore, no inverse.
Does
Or
not exist.
we'll put, therefore, inverse does not exist. Inverse DNE. And then, yes, you are done. That is the final answer. So, as the next line says, so back in the day, before we had calculators, determinants were very helpful. Why? Because depending on what the determinant was, if it was something other than 0, there would be an inverse. If it was 0, there would be no inverse. So that's as useful as it was. It really wasn't that useful either, but now we have calculators, so we don't got to do any of this by hand unless it's on the calculator inactive section of your SAT or ACT. And now I'm done.
Go. Okay, we're gonna. If you don't have your calculator, friends, I need you to get out your calculator while Fish is dancing. And so now let's see. Okay, yeah, you gotta do the shoulders.
Oh yeah. Sorry. Next time.
All right, so using the calculator. So we learned how to type this in. Hopefully I can do this a little bit quicker. So you go to second matrix right there. I'm going to go over to edit. And the first thing they have right here on my screen is a 3 rows by 3 columns. So I'm going to do a 3 by 3. And I'm going to start typing them in. 1, -2, 1, 3, 1, 0, 2, -5, 2. Okay. Once I get it all typed in, I do second quit. I'm going to go back to second matrix. Now there's this nice little function called math in the matrix thing. So it's not the same thing as if I hit my math button right there. To get to this, you have to go to second matrix. And it wants me to find the determinant. So guess what? It's that option right there. So I'm going to hit enter. And I'm going to do second matrix one more time because you have to take the determinant of something. If I were to just hit enter with no A there, you're kind of be like, error, you're doing something wrong. So my determinant is -3. We wouldn't even be able to do this by hand right now unless I was one of those people that wanted to go learn how to do it by hand and do Kramer or something. So, yeah.
How come we can't just use like absolute value?
No, fish. Those bars, when it's a matrix, don't mean absolute value. They mean the determinant. Good question. You can't just take the absolute value of everything. That's silly. Silly. This is the absolute value. If it was like that.
Oh, gotcha. That makes sense.
Yes. All right. Now I'm going to do another one. So second matrix. I would pause the video, y'all, and I would see, can you do this one on your own in the calculator? So pause me. Welcome back. Whoops. -6. 10, 0. This takes a long time, y'all. But it's okay. It's probably way faster than doing it by hand.
Way faster than Kramer's rule.
Way faster than the 2x2 too.
I typed it in. You can technically scroll up there since we put it in A and just hit enter. But for those people that still need to see it, second matrix, scroll right to math, enter, and then I have to do second matrix again, enter, enter. And I don't know how I end up typing that 6 there. That 6 isn't supposed to be there, but it showed up. And my answer was 390.
Whoop, whoop.
All right.
Is it supposed to be that big?
Huh?
Is it supposed to be that big? How come one was -3 and the other one's 390?
You know, I don't see why. Huh?
I don't think it matters. I think as long as the number is not 0, like I mean, the number can be whatever, honestly. I think it's just if it's 0, we can't find the inverse. So I think 390 and -3 are cool.
Yeah.
Okay.
I don't think there's anything wrong. All right. Let's go to example 5. Now, let's see. I'm going to go to second matrix and I'm going to go to edit. This time, though, it's a 2x2. And it just gets rid of it. So if you don't like that there's already numbers there, guys, remember you can always clear your calculator every time. 2 + 7, 1, 2. So I typed it in. I'm going to go back to the home screen because I always do that. And I'm going to go to second matrix. Now, let's see. I'm looking for inverses. Huh.
Is inverse the same as that little -1 power?
Yes, Miss Marshall. You are so right. So all you have to do, this is no math button here. So inverses. So remember when we were doing like trig, and you had the sign inverse, you put that little negative thing. So when we're doing this, we're going to put A in the calculator with a little -1. Isn't that nice? That's so nice. All right.
So you mean we don't have to find all that determinant stuff?
We don't have to do nothing. Nope. It's going to do it all for us.
So I can ignore Miss Marshall's whole section?
Exactly. Say bye-bye. No, because the SAT does have a non-calculator problem. So, yeah. So, I got a bunch of decimals. You can also, guys, if you hit math, enter, so math frac, it will change it to some nice fractions. So, either or is fine. If those decimals didn't stop, I would always change it. So, I don't know what the answer is. 3 halves, -2, -1/2, 1. 3/2, -2, -1/2, 1.
So
All
which
right.
way do you want me to write the answer? Like, you want me to give you the fraction and the decimal matrix?
No, whatever your heart desires. I mean, but if I say exact, guess what, friends? This is not
You
exact.
gotta do it. A decimal's exact.
I know, but I mean, I guess if it was repeating, you would not be able to write it down, or it was a not terminating decimal.
Like, I couldn't write down 0.333333333 and just
No,
write all the threes that show up on my calculator screen?
no, that's not
That's
exact.
exact though.
No,
So I just need to write 0.3.
no, you have to change it to a fraction
Oh, okay.
if we say exact. Now, I guess you could have written 1.5, -2, -0.5. That would be exact as well because they're terminating decimals. Terminating means it ends. Whoa, okay. 2, okay, 1, 2. I would be pausing my video, y'all, so that you can get the answer. It's really easy, though. And then you can just do second matrix, enter, and then the matrix button and the inverse button are the same button. So if I don't have to hit second to get the inverse. So I just hit enter. Woo!
This one's gross.
I know. So
I must
this
have did something
one,
wrong, or you did.
you can, what?
Did you do something wrong?
No, I got it too. And it's all these gross numbers. But I changed mine to a fraction already.
This is the example that if you sat here, so if you scroll over, you can see the decimals. But if you wrote all those down and we said put exact, guess what? -2 points. So math, enter, enter. Okay, that's the answer, guys. Are we okay if I don't write that down on my paper? Everyone?
Just take a screenshot or pause it, guys.
Yeah.
I think we're okay.
Okay, so second, I'm going to go ahead and do the last one. Second matrix. Again, I would pause the video. See if you can do this. Hopefully you're back now. 1, enter, 4, enter, 2, enter, 8. And then, ooh, I messed that up. 4, 2, 8. Enter. All right, so then I do second quit, second matrix, and I select my matrix, and I do second, nope, no second. Then I hit the matrix button. Oh my goodness.
Your calculator's broken.
Oh
It's
gosh.
broken. No, it's not. So when Miss Marshall was going over it, like if you can check this too, let's see if I didn't make a mistake. So I'm going to see if my determinant is 0, because if it's 0, then I don't have an inverse. So 8 minus 8 equals 0. So there is no inverse here.
Could I have just done the determinant in the calculator and like not did 8 minus 8?
Yeah, you could have, but
Oh.
you know, yeah, you could. All right. So example 6. These are our last two, friends. You're probably thinking, oh my gosh, when they all make the video, they're so long, but it's so much more fun. If you printed off the notes, though, your B might be different. So we changed the B last minute. If you printed it, I'm going to fix it on Google Classroom, but make sure your B matches mine. If it doesn't, just scribble it out and fix it, okay? All right, so we are solving for X. So like Miss Marshall said, so if you remember in her notes, we can't divide, so we have to do what?
Multiply by the inverse.
Yes. So when I'm doing this in the calculator, I'm going to do A inverse. I'm going to call this A and B. A inverse times B. Right? Right. All right. So you
Could I
can't do
just
it
do
the other
B
way.
times A inverse?
No. When you're solving, it needs to be in the order so it's in front of X, so it's going to be in front of B. If it was behind X, then it would be behind B. So it needs to match what it looks like in the problem.
Mm.
Yeah, good question. Good question. So second matrix. Oh my gosh, this is a lot. It's a lot of work if I wasn't doing it on the computer, but you know, it is what it is. All right, so 2, enter, -3, 4, 1. Okay, and I'm gonna go back to second matrix because I need to do the other one. I'm gonna put that in B. It's a 2 by 2, and it's -5, 0, 3, 6. So I like to write, so you see in my green, I like to write it out because that's what I'm going to put in my calculator. So I'm going to go to the home screen, and I'm going to put that without the X. Oh my gosh. So I'm going to do second matrix. I'm going to put A, but then I have to put the inverse there before I put the other one. Otherwise, you're going to have to scroll over and insert it. And then I hit enter. OMG. That's a mess.
Ew.
I
But we can
know.
change those to fractions.
Yes, we can. So, wait, I messed up. Math, enter, enter. So there's the answer. I'm not going to write it down because it's too hard to do right now. Do you think that there's a way that I could check to see if this is the right answer? Does anybody
You
have any ideas?
can, if that's X, you could do A times X.
Yes, fish.
Oh,
So
can
I'm
we
gonna
like
see.
store that as the X?
Oh, even better,
Oh.
Marshall. Okay, so I'm going to hit stow. So if I hit stow, I can stow this as X and hit enter. So now, no, I can't.
Oh,
Oh,
shoot, we can't do that.
Oof.
Learning
Okay.
no, it doesn't
something.
like
So we
that.
can't.
I didn't know we weren't allowed to. So I'm going to go a different method. I'm going to hit A, and then I'm going to scroll up and say multiply it by this dude. Oh, I guess I can't check my answer.
What if you click on the matrix and then once it's like solve it again and press second answer or second enter?
Oh yeah, go up one more. Like go up. No.
Not oh
Okay,
yeah,
no.
that. And then oh, I don't know if it's gonna work.
Enter.
Yeah.
Yeah.
So I have to do, ooh, this is maybe this one. Can I do this one?
Not that one yet. You gotta do A first, right?
Oh, I know what you're doing. Okay, so A, so you guys are like, oh my gosh, these teachers. So I'm going to do A times my answer, like that.
Yeah.
So I'm going
Yeah.
to enter. Woo! There we go. That was too much.
Yeah.
Yay! It
We
works
got it
though.
right. We got it right. All right, last one, last one. All right, so when I'm solving this one, I'm going to end up, so I'm going to call this A, and I'm going to call this B. Now, since X is in front of A this time, B is going to go first times A inverse to get my answer. So it matches the order. Again, guys, that's how we know. That's the tricky part with these. You can't just go willy-nilly. Ooh, I'm going to do B times A. I'm going to do A times B, whatever my heart desires. No. All right, so I'm typing it in. Whoa. -1, -2, 7, 3.
It
And then,
stayed as a -10.
oops. Okay, let me fix that. Thank you, thank you. That would have been real bad. Guys, if you aren't pausing the video right now to see if you get the same answer as me, but for how slow I'm going, you probably will beat me. 2 by 2, -4, 1, -2, 1.
Oh, it stayed a +2.
Oh my gosh, this is becoming too much. I hope that didn't mess up on any of the other problems.
No, I don't think so.
Okay, so I'm going to do B times A inverse. We're all getting emails.
Yeah, we just all got the same
They
email.
want us to check it.
All right, that's what I got, but I'm going to hit math, enter, enter. There is my answer that I got. And again, can I check this
Whoa.
answer? Yes, it is gross, but you know, it's okay. So I could just do, to see if it's right, we would do the answer that we just got there times matrix A and see if that gives me, oh, it's so nice.
And it does. Whoop, whoop.
Oh,
Yes. So friends, that's it for us, unfortunately.